Algae. It's green, it's a plant, and it grows in the ocean. But you know what else it's useful for?
Eating? Seaweed is an algae.
Well, yes, some types of macroalgae, such as seaweed, can be processed for human consumption. But there have been recent advances in technology that allow us to process certain microalgae into biofuel.
That's interesting. But isn't a biofuel incompatible with gasoline engines?
No, actually, we wouldn't need special engines for the biofuel, which is why this advancement is so intriguing. If the biofuel production is scalable, it could replace the gasoline in our gas stations.
Well, this innovation would help our depleting supply of fossil fuels. But in terms of releasing greenhouse gases, they are both the same.
There is a difference. Biofuels would be carbon neutral since they're absorbing carbon dioxide from the atmosphere and then releasing them, which means the total amount in the atmosphere is the same, while for fossil fuels, they are adding additional carbon dioxide into the atmosphere.
Okay, if this works, it sounds great. But how does it actually work? How does a plant turn into fuel you put in your car?
Well, first, you have to grow the algae. This is usually done in so called racetracks. Then, you have to harvest the algae, remove the water in it, and extract the algae oil. After that, you'll have to refine it into various grades of oil in a process similar to that of crude oil. And the biofuel produced by the algae is mostly biodiesel.
You say that algae is grown in racetracks. I'm assuming you don't mean actual racetrack.
Oh, of course not. It's shaped like a racetrack, but they're filled with water and open to the sky. There's also a paddle wheel that moves the water along in the racetrack. It prevents the algae from sticking to the bottom of the racetrack.
Well then, after the algae has grown in these racetracks, how do you harvest it? Would you run it through a filter?
Well, remember, we're growing microalgae. Micro means we can't see them with our eyes, and if you took a glass of water with the microalgae, it would appear to be a uniform green color.
Then what's the proper technique?
That's a great question. Well, there's an alternative technique called flocculation. As you know, everything is made of atoms, including algae. The surface of the algae also has a charge on it, like atoms. So when a chemical such as aluminum sulfate is added, it bonds with the algae and causes it to separate from the water.
Oh, I see. Then what's special about the aluminum sulfate?
Well, when you put aluminum sulfate in water, it disassociates, meaning it breaks up into various ions. And an ion is just an atom or molecule with a charge to it. So you'll remember from school that opposite charges attract.
Okay, and I remember you said that after we harvest the algae, we would have to remove the water from it, right? Let me take a guess. We could let it dry in the sun, or we could use some chemistry magic.
It's not magic, and sun drying is a valid technique that doesn't use energy, but a faster way that does use energy, and it's putting the algae into centrifuge.
Oh yeah, I know what centrifuge is. It's a device that rotates rapidly, and it causes the contents to separate out depending on the mass. Since heavier mass will experience a greater force.
Correct. It's a similar feeling to if you rotate your arm quickly. You'll feel the blood getting pushed towards your finger. Then, the next step of the process is to extract the oil from the algae. Before we get to that, you know when you get oil all over your hands?
Yeah, what about it?
What happens when you try to wash it off only with water?
Well, it's pretty difficult to wash off. I usually have to use soap to get the oil off.
Well, let me tell you the reason for that. The reason is that water is actually a polar molecule, meaning that different ends of the water molecule have partial charges. As oil is a non-polar molecule, there are no partial charges, and because it dissolves like, the water will not dissolve the oil and will make it hard to clean. But that also means a nonpolar molecule will dissolve other nonpolar molecules. So we can actually use nonpolar molecule known as hexane to dissolve the oil in the algae.
That's pretty cool. And since the water is polar, does that mean hexane won't dissolve in the water, right? That's pretty useful.
Yes, and after the algae oil is distracted, it is processed similarly to crude oil. The algae oil is heated at the bottom of a tower until it evaporates.
But won't heating it cause it to combust or cause it to explode?
Not necessarily. It's important to note that we aren't combusting the oil, since we aren't providing a spark, since the oil is actually heated at the bottom of the tower, so the ambient temperature decreases as you go up the tower.
Oh, I see. So when the water vapor begins to rise, it begins to cool. And when it condenses back into liquid, it varies in heights. so we can see it separate the oil into different grades?
Yup, and crude oil is actually processed in this way, and it's known as the process of fractional distillation.
That's pretty cool. You said that a normal gasoline engine can also run on biofuel, but there's a difference, right?
Well, yes, they aren't exactly the same, as the crude oil we refine into diesel is a hydrocarbon, meaning that the diesel molecule is made up entirely of hydrogen and carbons. Um, Biodiesel, on the other hand, is mainly hydrogens and carbons, but it does contain an ester functional group. All that really means is that essentially there is also oxygen atoms in the structure of a biodiesel molecule.
But is the oxygen a bad thing, or would it make the engines run more efficiently?
The oxygen, in the grand scheme of things, is not significant to the energy generated in a conventional engine, but it does mean that the diesel is able to generate more energy per liter than biodiesel. The technical term for this is that the diesel has a greater energy density compared to biodiesel. To be specific, it's around 13% or greater.
Oh, okay. So the oil in the algae can be used to create biodiesel. But what about the rest of the algae and the biomass generated in the process? Is that thrown out? Or can we repurpose that biomass into something useful?
Well, that's a really great point, and it actually can be fermented. So the biomass can be fermented and will produce bioethanol, which is very useful for many different applications, such as gasoline additives, plastic manufacturing, and other things such as topical antinectives.
Dang, this algae thing seems pretty promising.
Yep. The only problem is that the scalability of converting algae into biofuel is not very promising with current technology.
Perhaps with more advancements in technology, this method of biofuel production could be implemented widely.
Yeah, and while there are scientific challenges, they also have many other forces working against them. One of them is big oil corporations lobbying against them because they see this new technology as a threat to their market share in the energy industry.
Well, educating people about this new technology is probably the best way to counter that.
I agree, and all we can do to really help with this issue is, talk more about it, increase discussion, and, teach others about it,
Oh, oh, this is very useful information. Thank you, Afnan, for telling me all of this.
Yeah, and thank you, Lawrence, for giving me a chance to explain.